Today, we'll be taking differentiation on mathematics. What do we mean by differentiation? What is differentiation? Differentiation, by definition, is the process of finding the derivative of a function. The process of finding the derivative of a function. And derivative of a function, f of x, derivative of a function, let's say a function f of x, derivative of this function is either the gradient or the rate of change of that function. If the function is y, let's say we have y equal to x. If this is a function, the derivative of this function is the gradient of this function or the rate of change of y, rate of change of y with respect to x. It is denoted as dy over dx, dy over dx, dy over dx. So the differentiation is the process of finding the derivative of a function, and derivative is the rate of change of a function or the gradient of that function. So today we'll be differentiating using the method of first principle. There are different methods of differentiation. There's a general method of differentiation. There are different rules under differentiation, but today I'll be taking the first principle of differentiation. Let me start with examples. Let's say you have to find the derivative of each of the following function by first principle. We have y is equal to x squared. 2, we have y is equal to 1 over x. So 3, we have y is equal to x cubed. 4 is equal to y all over 1 over x squared. So these 4 questions, I'm going to solve 2. Then you will try these 2 also. You can try these 2 as exercise. So let's start. Using first principle, let's say we have the first question say y is equal to x squared. Follow me carefully on this method of first principle. How do you differentiate using the first principle? The first step is to increase y and increase x. That is, if y is increasing with respect to y, x also should increase with respect to x. So y plus change in y is equal to x. Anywhere you see x, you increase it with x. Change in x squared. That is the first step. Let there be an increase in y and let there be an increase in what? X. Y plus change in y, x plus what? Change in x. So let's continue. Here I'll have y plus change in y equal to, this square means twice of it, x plus change in x multiplied by x plus change in x. So we can expand from here. Are we together? So this is square, twice of it. So y plus change in y. So y plus change in y will be equal to, let's expand this. I've explained expansion severally, but expansion means you use this to multiply this. Use the first one to multiply the last one. Use the second one to multiply this. Use the second one to multiply the last one. X multiplied by x is x squared. X multiplied by change in x is x change in x. Change in x multiplied by x is x change in x. Change in x multiplied by change in x is change in x squared. This is plus change in x squared. So x multiplied by x give us x squared. X multiplied by change in x give us x change in x. Change in x multiplied by x give us x change in x. Then change in x multiplied by change in x give us change in x squared. That is the second step. The first step, let there be an increase in the both sides. The second step, you expand this. Now let's complete the expansion. Y plus change in y is equal to x square plus 2 changing x changing x and x changing x give us 2x changing x plus changing x square. So this is y plus changing y equal to what? X square. So after this step, the next step now, after this expansion, the next step is to take y to the other side. Take y to this side. So what will be, I'll be left with changing y here equal to x square plus 2x changing x plus changing x square. Getting to this point, you take y to this side. When you take y to this side, becomes what? Minus y, because here I have plus y here. So changing y will be equal to x square plus 2x changing x plus changing x square minus y. Don't forget, our y is the same thing as x square. So anywhere I have y here, I will substitute as what? X square minus x square. So if you proceed from here, you will see that this is plus x square. We'll cancel this minus x square. Plus x square minus x square will cancel each other. So we'll be left with 2x changing x plus changing x square. So this is the third step. The first step, let me recap the step: an increase in y with respect to y. Let there be an increase in x with respect to x. I expand it. After the expansion, I arrived at this. The second step, the third step, the first step is increase. The second step is expansion. The third step is to collect like term. That is, take y to this other side. After taking y to this other side, the fourth step is to substitute for y. Our y is x squared. So when you substitute, you notice that this and this cancel each other. We are left with this. So the next step now is to divide through by changing x. Divide through by changing x. This side also by changing x. Changing y over changing x is equal to, this changing x will go with changing x. I'll be left with 2x. This is 2x squared, and this is changing x. Changing x will reduce square of this. We'll be left with changing x. So this is the fifth step, is to divide through by changing x. The next step now is to take a limit. When you are taking limit, you change your changing y over changing x to dy dx. You limit as changing x approaches 0. The meaning of this is that anywhere you see changing x here, for this side, you change it to dy dx. For this side, anywhere you have changing x, you limit it to 0. So this is 2x plus 0. So dy dx will be equal to what? 2x. So I have differentiated this using first principle. This is our final answer. Let me recap the step again. The first step, let there be an increase in y and x. After that, when you increase it, you expand. After expansion, you take y to this other side. When you take y to the side, you substitute for y. When you substitute for y, you divide through by changing x. When I divide through by changing x, I arrive at this. The final step is to take a limit. Take limit as changing x approaches 0. That is, anywhere you see your changing x, turn it to 0. Then we have our final answer to be 2x. One more example on first principle. The second example there, equal to 1 over x. This will be the last example. Okay, this will be my second example. Y is equal to 1 over x. Using first principle. Don't forget our step. The first step, let there be an increase in y with respect to y. And let there be an increase in x with respect to x. Y increase, x increase also. So when y and x is increasing, they will increase with respect to themselves. So from this point, this doesn't need expansion. So from this point, we'll move to taking y to the other side. So this is 1 over x plus changing x. When y comes to this side, it becomes what? Minus y. So this is changing y equal to 1 over what? X plus changing x minus y. Y represents 1 over x. So instead of this y, I will substitute with 1 over x, which is our question. The next thing now is to solve for this. if you are to solve for this, you take the LCM. This is a fraction. You take the LCM of this and this. The LCM will be x into x plus change in x. When you multiply both of them together, it will give us our LCM. So if you are to solve for this now, let this divide this, we'll be left with x. X multiplied by 1 will give us x. I come again. This will go with this because this is the LCM. We are using this to divide this. This will go with this, will be left with x. X multiplied by 1 will give us x minus x. X will do away with x, so we'll be left with this. When you use this to multiply 1, it gives us that same thing. So this is x plus change in x. So change in y will be equal to what? X. Let's use minus to expand this. This will be minus x minus change in x. Minus x minus change in x. All over what? X into x plus change in x. So this is plus s, this is minus s. They will cancel each other. So this is change in y equal to minus change in x all over what? X into x plus change in x. X into x plus change in x. So from this point, we can say divide through by what? Change in x. This is the next step now. Divide through by change in x. So this is equal to minus change in x divided by x into x plus change in x divided by change in x. So change in y over change in x is equal to minus change in x all over x into x plus change in x multiplied by 1 over change in x. When you are changing division to multiplication, you take the reciprocal of this. So this will cancel this. I'll be left with change in y over change in x equal to minus 1. Minus multiplied by 1 give us minus 1. X into x plus change in x. Getting to this point, the next thing is to take a limit. The final step, you limit change in x to 0, and you change in y over change in x to dy dx. So limit as change in x approaches 0 of dy dx. So let me write the final answer here. Dx will be equal to minus 1 x into x plus, instead of changing x, it will become 0 because I'm limiting it to 0 now. So finally, we'll have our final answer to be dy over dx equal to minus 1 over x multiplied by x give us x squared. So this is our final answer. This is our final answer. If you have watched me to this point, please do well to like, subscribe, and share. And I've solved 2 questions. You can as well try the other 2 questions. Thank you very much for watching.